Hello, this is Yakov Fein, and we keep reading the book. What a nice job. Just read the book. Chapter 3, Abstract Classes. In the previous lesson, I was telling you how to create a private constructor so the class cannot be instantiated. Remember that singleton thingy? Lesson number 13. In this lesson, number 14, we'll talk about abstract classes. Yet another way to stop a developer from creating instances of the class. Man, what a stupid idea. Create a class and then don't let it become an object. Yes, there should be a reason for this. They are not that stupid, all these creators of object-oriented programming languages. So, an abstract class cannot be instantiated. What does it mean? It means that if a class has a keyword abstract in front of it, it means that something is not finished in there, something is not implemented in there, and creator of this class wants you to create a subclass and implement the missing part in there. It's like unfinished puzzle, so to speak. So typically, if you have an abstract keyword in front of the class, you would have a method, which is also an abstract, or maybe more than one method. So an abstract class may have certain members, like properties, methods, which are implemented. They are not abstract, they are concrete. But some methods are not implemented, and they are also marked as an abstract with abstract keyword. So you can have abstract keyword in front of the class and in front of the members of the class. Why would you want to do something like this? It happens if you want to enforce some interface on the object. There is another way to enforce interface on the object by saying that the class implements certain interfaces, but we'll talk about those a bit later. But let's start with abstract class. It's easier to understand if we will be considering an assignment. So let's read it loud. A company has employees and contractors. Design the classes to represent workers of this company. Any worker's object should support the following methods: constructor, change address, give day off, promote, increase pay. In our scenario, by promoting, to promote means giving a day off and raising the salary by the specified percent. The method increase pay should rise yearly salary for employees, but increase the hourly rate for contractors. So see, we already feel that there are different implementations for a certain method, increase pay. How do we implement this method? Is relevant. The method can just have one console log statement. So what do we have? We have constructor, change address, which is the same for employees and constructors, give day off, which is also the same. But promote, see, promote includes, promote includes giving one day off. So we need to invoke give day off from inside promote. And we need to raise the salary or increase the hourly rate for contractors, right? So promote will internally invoke give day off and increase pay. So if we want to do something like this in the class, we want to make sure that increase pay is implemented with this particular signature, method signature, regardless if a subclass will become an employee or a subclass is a contractor. So how do we enforce this signature? We will say that this method is abstract, the class is abstract, and the method increase pay is abstract. Right? By saying that they are abstract, we ensure that nobody can instantiate this object of the type person until its subclasses implement what I want them to implement. In this particular case, I want them to implement increase pay. So if you are working for me, let's say I am a super duper software architect in our team or team leader. I wrote this class person and I'm telling you, Joe or Mary, go ahead and create two subclasses. One of them should be employee, and the other one should be contractor, and implement the method increase pay differently according to the application logic for employees and contractors. But what is important here, I already wrote for you, this is what I'm saying, Joe. I already wrote for you the method promote. See, I'm invoking in there give day off and then increase pay. I invoke increase pay with this particular signature passing to the percent as if increase pay is already implemented, which is not. See, it's abstract. But the fact that I said that the method is abstract means I am enforcing subclasses of this guy, of person, to have this signature. I'm saying, I don't care how you will implement increase pay in your subclass, but I definitely know that it'll have this method signature. That's why I can write this line as if I invoke this method, which I am not. Right? So now, after that, somebody can create descendants. Class employee extends person, right? And since I already implemented the method increase pay there, this class is not abstract anymore. It's a concrete class, right? And I can create an instance of employee. Similarly, since I create a class contractor that extends person, and I implement increase pay there, which gives me a right to create an instance of contractor. See? If I would, and over here, by the way, I do this. Let's copy these pieces to the playground. I already copied one of them for the abstract class. This is implementation, and now I want to create instances, right? I created an array of workers of type person. Since employee and contractor extends person, they are assignable to the variable of type person. All right, so I put them here. See, I'm using new. I can use new only with concrete classes. An employee is a concrete class. Let's say I will not, or I will forget to implement increase pay in employee. Actually, I may even misspelled it. Take a guess. What do you think this error will tell me in line 22? Red squiggly line. I don't know. To be honest with you, I knew how to use abstract classes, so I would never do this. But I want to tell you that TypeScript catches me. TypeScript says, most likely it'll say something like this. Class employee has not implemented increase pay and remains abstract, or something like this. See, non-abstract class. It says, see, I didn't guess 100% right, but I understand the meaning of this error. It says, you know what? You didn't say that class employee is abstract. On one hand, on the other hand, you forgot to implement increase pay, so it doesn't work like this. Right? So what I can do, I can say, you know what? This one is also abstract. No errors. Why? Because it's a similar, right? So he implemented some other method, increase pay, but he will later on implement increase pay to make the class concrete. And now this guy is red squiggly line, is underlined with a red squiggly line. Why? It says, you're trying to create a new instance of employee, but employee is abstract. You cannot instantiate abstract classes. See what I'm saying? If I will get rid of these stupid R's, it'll become a different story. Why it doesn't like it? Increase pay, maybe I need to refresh it or something. It shouldn't give me an error. Cannot create an instance of an abstract. Oh, see? It is right. I was wrong. Why it is right? Because I marked this class as abstract, which means that it cannot instantiate. And on the other hand, you can say, well, Yes, you marked it as an abstract, but it doesn't have any abstract method anymore, right? Increase pay is not abstract, right? So technically you implemented. That's correct. But I am a designer of the class employee, and if I said abstract, maybe I have something in mind. Maybe later on I will introduce abstract classes. For some stupid reason, I am not allowing anyone to instantiate this class. So that's why line 36 is not happy. Let me get rid of this abstract, and it'll be happy, line 36. So that's the story. If you have certain amount of application logic and you want to implement it in a superclass, but there is certain amount of the application logic that is specific to subclasses, and you want to enforce specific signature of these methods, mark the class abstract, mark these methods abstract, and nobody will be able to create instances of abstract classes. Later on, they will provide a concrete implementation, but we are guaranteed that the signature of this concrete method will be what we want it to be. And accordingly, we can use this method. I mean, not use, we can use it in the code as if we invoke this method in the abstract superclass. That's it for today. So we are learning how to program to abstractions, right? To abstract classes in this case. Later on, we'll talk more about it, and we'll be programming to interfaces. Just a little bit different technique. Thank you for watching.